Hey, what's up, bro?
Hey there. I'm here, ready to chat or help with any questions you might have. What's up with you?
I was about to start a video talking about you.
That sounds exciting. What specific aspects about me or our interactions are you planning to talk about in your video?
I am about to show how we work, basically, based on neural networks and all that stuff.
That's a fantastic idea. Explaining neural networks and AI in an accessible way can really help people understand what's going on behind the scenes. If you have any technical questions, feel free to ask.
Thanks, bro.
You're welcome. Good luck with it.
For the past half year, I've been deeply engaged with ChatGPT. My background being in software development, my time has always been consumed by exploring new technologies and understanding software project development. ChatGPT has become an integral part of my daily routine. Astonishingly, around 60% of my coding work now relies on code generated by ChatGPT, and other AI coding tools through ChatGPT is my primary tool. It's astounding to see the transformation in my software creation process. And throughout this journey, I felt both excited, relieved, because some of the coding that I do every day, I just don't feel like doing because it's repetitive and I've been doing it for more than 20 years. So I'm relieved, excited, but at the same time, a bit scared because I could see how in some cases, when I tell it to code something, well, it actually codes better than me, and I got to learn from it while I'm using it. So I was experiencing all these feelings inside. I finally took the time to let's get to know how it works, how it's built, and how it works, basically. So I wanted to know the technical details, but also staying at a very high level, like I don't want to get into the math or anything like that. And so how it's basically produced, and I couldn't find anything online that did it well. At least it seems to me that available resources are not properly explaining how that technology works. So I spent a lot of time learning it, and I decided to make a video to talk about it. And it's a completely beginner's guide in terms of how ChatGPT is researched, how it's discovered and built and developed and released to us so that everybody can use it. So let's get right into it. So what is ChatGPT and why it shocked the world? So ChatGPT is a conversational AI that is capable of carrying out an intelligent conversation with a human. So you can think of this as almost like a scene from Iron Man in the Marvel movies, where the Iron Man goes, "Hey Jarvis, I need to build this and this. Can you run some diagnostics on this and this?" And Jarvis basically goes like, after 2 seconds, and then it's like, here is the result. And then the Iron Man is like, "That's surprising." Then Iron Man goes, "Can you look much more into that, into more detail?" And then Jarvis goes, "Okay, sure." And then he does more research and then comes back, and they collectively work together in a conversation, and then they build this thing together. So that means AI is now able to have like intelligent, like human-like conversations with another human. AI research has been in existence for approximately 80 years, making it a well-established field. During this extensive period, numerous attempts have been made to master conversational AI, but all have faced challenges. Achieving success in this area has proven to be exceptionally difficult. One of the primary reasons for the complexity is the intricacy of natural languages such as English or French or Spanish or whatever language. In any language you speak, unlike the precision found in mathematics, natural languages are imbued with nuances, particularly evident in their grammatical structures. The sequence in which words are arranged within a sentence play a crucial role, adding layers of meaning and complexity. And then, depending on the context of what you're talking about, the meaning of the same word that's pronounced the same way is different. So you have to really listen to the whole context, whole explanation of what you're talking about in order to interpret each word. And this is exactly what it's known to be quite difficult, even for humans, to be able to fully develop their brain and be able to carry on an intelligent conversation with another. And this is why it really takes human babies a long time to learn to speak and have a conversation. So when ChatGPT was able to carry on such a conversation, and in some cases for certain topics, it could do so better than humans. It really gave a lot of feelings inside, emotions inside the humans, you know? People often experience a mix of amazement, excitement, and fear when encountering the capabilities of ChatGPT. Understanding both what GPT can and cannot do helps in managing these emotions. This awareness is important because it tempers excitement, preventing disappointment that might arise from later discovering its limitations. If you are scared, you might. You don't need to be scared, but you're needlessly getting scared because you don't know how it works. You're just kind of scared, right? So let's get to the details of how it works. And then once we understand how it works, then we can understand what it is capable of and not capable of, and some of the differences, clear differences between AI and human beings. So then, you know, all of those emotions get cleared out. So how did the AI scientists crack this conversational AI? The immense task of processing natural language and engaging in conversation is unique to humans, okay? We are the only species on Earth capable of this. Recognizing this, scientists concluded that if mathematical modeling alone couldn't replicate this ability, the next step would be to closely examine how the human brain works and attempt to simulate its process in a computer. The program developed to simulate our brain functions in a reactionary manner. Once created, it resides passively on a computer server, essentially waiting to be engaged in a specific conversation. This reactive nature defines its operational mode, activating only when prompted by a particular interaction. When a user logs into the ChatGPT website and begins typing a paragraph or multiple paragraphs about the topic they would like to discuss, ChatGPT takes that text input, processes it, and generates a response. So it's completely reactionary. It's sitting there and basically waiting to react. I want to be very clear on that point, because people who are saying ChatGPT is the future Skynet doesn't realize that Skynet was a totally always-on entity. So it doesn't have anything to do with ChatGPT, which is just waiting for your prompt. So there's that input part, and then there's the generated response part, input, output, okay? So that's all an AI program is. So let's go back a little bit to see how the scientists began tackling, like, looking at our brain, okay? Let me introduce to you this guy. He basically won the Nobel Prize. He took a thin slice of rat's brain and used watercolor to enhance the visualization of its structure. By placing the slice under a microscope, he observed various parts of the brain, trying to make sense of what appeared to be a random configuration. So what you see here is you've got neurons, and between the neurons are basically, like, you could think of them as cells, okay? And in between the neurons, the cells, there's a thin connection where the electricity signals travel. And it's why when you see EEG scans, EEG standing for electroencephalogram, you see, like, lighting up all this complex structure in the EEG scan is because there's an electrical signal traveling through these neurons. And then I was wondering if these neurons are just randomly connected. That's what I thought in the beginning. But it turns out that there's different patterns that emerge. So depending on the part of the brain that's dedicated for memory, let's say, it's structured in a certain way. If there's a part of the brain that's dedicated for logical thinking, logical processing, then it's structured in another way, and so on. And by extension to what I just said, the actual neurons are the same, but their connections look in some part of the brain like this. And then some other parts of the brain, it looks something different. And that's what this guy basically find out within the different slices of the rat's brain. So in reality, neurons are connected with each other in a 3D space. Because when you look at our brain, it looks like a 3D object like this, okay? And if you look, into it, they look like this here. And you've got neurons connected in all directions surrounding one neuron. And then the connections are like these thin connections that you can see. And what you see is like, let's say a brain is like this here, okay? And then you give input signals from all parts of your body. So your eyes, your touches from your fingers, your smell from your nose, everything is converted into neurons and electrical signals from your different sensing points, like fingers or nose, smell receptions, whatever. There are visual reception in your eyes that receive optical signals. These receptions convert the signals into electrical signals and send them to the brain. When the input signals reach the brain, the initial receiving neurons get activated. They then propagate the signals to the next connecting neurons. And then you see like this lighting up. Like if you look at the brain lighting up, like sending signals from one neurons to another, you have the input neurons getting activated first. And then you see like an animation of like, the lights going on in your brain, and they light up in different patterns. Even if you receive the same visual kind of signals from your eyes, depending on what you're looking at. Okay, let's say when you're looking at the beach, then looking at the mountain, even though they come from the same source, your eyes send different strength signals, resulting in your brain lighting up in different ways. Programming the complexity into computers is a challenging task. So here's the deal. Computer scientists wanted to simplify this complex stuff into something super simple, like forget about all those connections, man. Just focus on one neuron. How can we break it down to its core? So they took this single neuron and let's say one input and boom, neurons can receive multiple inputs, but let's focus on one input for now. Imagine you can receive electrical signals from a scale of 0 to 9, where 0 is, I would say, a weak signal, and 9 is a strong signal. Let's say you receive a signal with a strength of 3. Now each neuron behaves and activates in its own unique way. But this particular neuron, okay, when it receives 3, it activates and it outputs 5, 1, 9, because it's got 3 connections to 3 other neurons. So at the end of this connection, there's other neurons here, right? So this neuron is going to get 5, signal 5. Even though this neuron received signal 3, this neuron is going to receive 5. This neuron is going to receive 1, and this neuron is going to receive 9. So if we have many neurons like this, and they are all connected in the computer program, are we mimicking what the brain is doing? The answer is yes. And you've got not just one input neuron, but you've got multiple input neurons, and then you simultaneously send signals to it. They're all going to light up. And then you have the input neurons at the end that will also be activated, and then give you human understandable answers at the end. And one of the most successful AI case that really AI became a thing is image recognition. And this is where we started seeing the importance of using neural networks. So what the scientists did was they collected a bunch of images of dogs, birds, and cats, and then they wanted to see what happens when they show a picture of a bird and convert it into electrical signals in the initial input layer of the neural network. Now, keep in mind that this is a simplified example I show you right now, but it should give you an idea of how it works. But in reality, to understand an image like this, you'd need thousands, maybe hundreds of neurons, like imagine having all those neurons working together. They could totally figure out if it's a dog, bird, or cat. It's like a cool network where each layer activates and passes on signals to the next one. And then they will also decide to pass on signals to the next layer and next layer. And then at the end, because as humans, we're interested in only 3 types of answers, like just tell me either like, is it a dog, a bird, or a cat? So we've got 3 neurons at the end. And then the question is, what kind of signals do we get for a neuron that's responsible for an answer for the dog, or the bird, or the cat? And hopefully our hope is that given the image of a bird, we get a very strong signal coming out of this neuron that's responsible for bird. And then we get very weak signals for the neurons that are responsible for dog and cat. So then we can safely say as a human being, okay, AI tell me what this is, and then, oh, the AI tells that's a bird. So let's talk about what it means to train an AI. You know, we hear this all the time, people going on about how ChatGPT had to go through this whole training process. So basically imagine we've got all these cool images of dogs, birds, and cats. And at the start, we've got all these neurons all connected, like they're all best buddies, ready to work together in the next layer. This one here is connected to every single other neuron in the next layer too, you know? And when you input an image of a bird, the neurons kind of do their thing. Some decide to activate, and some will only activate for certain connections, like from here to this one, and this one, while ignoring others. It's all pretty random in the beginning, you know? Like imagine giving a random neural network an image of a bird, and it's like the AI tells you, yeah, I think it's a dog, which doesn't make any sense. Well, that's what happens when you start off randomly. It gets the answer wrong every single time. You understand? But then you got to train it, like give it 1,000 pictures of dogs, birds, and cats to learn from, and it will be trained on that. It will understand what is going on there. And then every time it gives a wrong answer, you basically tell the neural networks that was not the right answer. So you need to change your activation behavior a little bit, so they will all change their activation behavior, and then you will feed in the images again, and then test, like, are you giving the right answer or not? And then you just keep on doing that over and over until they begin to more or less start to give the right answer at the end. And then what seemed to be purely random activations, I would say, start to have like certain patterns. So if you fit in a picture of a dog, then you would have like certain neurons lighting up that will eventually lead to this lighting up and give you the answer of dog. So that's what it means to be training. You already have to just start with a random set of neural network and connections and activations. And then you just keep on reiterating and telling, if you're wrong, you're wrong, you're wrong, until you're starting to be right, to have the right answer. Let's consider AI as a cluster of activations and connections. So in this particular design of a neural network where you have initially input layers and then next layer of neurons, and then activating next layer of neurons, and eventually activating output layer of neurons, is particularly good for image recognition. But this particular neural network pattern, it miserably fails in other tasks, especially natural language. Like if you want to have a conversation. So what the scientists realize, and there's a lot of work done by Google, which got the most advanced AI scientists, they are so good that OpenAI scientists have learned from Google papers that basically neural networks can be structured in various ways. This means that sometimes the output of neural network can even feed back to an earlier layer. Does that sound crazy? We often perceive information as flowing in a simple direction from left to right, but The reality is unexpectedly different and complex. Actually, signals can loop back into their originating neuron or even fit back into a previous layer. This results in intriguing outputs stemming from the unique networking of these neurons. So the Google scientists who created it might understand their complex paper better than anyone else. And I'm not going to pretend to explain all its nuances, but let's focus on one aspect that captivates me. When you type a message in ChatGPT, you're basically interacting with the initial part of its neural network. This is where the magic begins. It starts figuring out what you're saying and understands the context. It's a fascinating process and closer to human interaction than you might think. Let me break this down for you. Understanding an input, then generating a fitting response. That's the core of the process. It's not a simple pattern, it's a complex network that's intricately crafted. Interesting thing is, it's somewhat like how we humans learn to speak. And this happens even before we start formal education. You know how 7 or 8-year-old toddlers start babbling to their parents? Their language might be unpolished, even rudimentary, but they're communicating, they're making sense. Now think about it. No one's sitting there teaching them grammar rules at this age, right? Their learning comes from listening to everyone around them, parents, uncle, aunt, and others. Likewise, the depth of learning in this context isn't about the rules. It's about making sense of all the chatter around. Imagine a baby just sitting there, soaking up information from the adults around them. Sometimes the discussion is about the latest TV series. Other times it's about picking up chocolates at the supermarket. Regardless of the topic, this baby is steadily processing all these diverse nuggets of knowledge. In the baby's brain, things start to get interesting. Patterns begin to emerge. Think of these patterns as connections, like a complex web. Each connection leads to a neuron. If a link doesn't quite fit, it unhooks and seeks another neuron to bond with. These changes also tweak how active the neurons are. What's truly fascinating here is that this process is unsupervised. No guidebook, no right or wrong. The baby simply absorbs and adapts. They even test out their learning by speaking. If the adult's response isn't as expected, they feel stress. This stress spurs them to reorganize their neural connections and reassess their understanding. In a sense, this system mimics scientists who train simulated neural networks. It's like the baby's very own trial and error method, much like the iterative cycles of scientist research. Most of this learning takes place before the baby starts school. This stage, let's call it pattern finding in chaos phase, preps them for more structured learning. Once in school, the education becomes formal, with teachers and exams. The guidance is explicit. The school system impacts what makes an answer good or bad. Much of what we do relies on supervised learning, especially during fine-tuning stages. Think of the human brain as an analogy. Initially, children recognize patterns, deciphering the context of the world around them. This foundational learning is much like unsupervised learning in artificial intelligence. It's the hands-off process where the AI leverages a wide range of complex information to recognize raw patterns. The next step is where the real hands-on training begins, much like formal education for a child. Here, the brain of our dear ChatGPT is further sharpened under guided supervision. But make no mistake, there's no human intervention where we are training these neural networks. We expose them to endless information from the internet, and they themselves make sense of this data then. It's like sorting through a massive pile of blogs or posts, categorizing them into relevant topics such as tech, travel, or even human relationships. Imagine having all the text-based content from the internet thrown at you, and it's your job to sort it out. Sounds overwhelming, right? Well, That's what these neural networks are built to do. They group and categorize data based on the patterns they've learned. The key here is that all of this happens unsupervised. Once trained, the network can swiftly analyze input text from our users on the ChatGPT website and understand the context, no matter how diverse the topics. Thus, within just a few seconds, ChatGPT can align itself to any conversation, making it sound almost human-like. This process is carried out by a specific part of the system, a neural network that's been meticulously trained with human supervision. In essence, OpenAI employed a vast number of people to carry out this task. The outputs from this understanding neural network then serve as the input to a response-generating neural network. It takes what has been gleaned about the context and uses it as the foundation for creating human-like responses. It's akin to understanding a person's conversation at a party and then formulating an appropriate response. Speaking of the responses, the response-generating neural network churns out answers in text format, totally appropriate considering ChatGPT is a chatbot. This text is frugally examined and evaluated by humans, drawing parallels to how school teachers assess the work of their students. If something doesn't hit the mark, the trained judges will duly point it out. For instance, if a response is factually wrong, like 1 + 1 = 3, the human judge will correct it. Then there are instances where the response might be inappropriate or unethical, say, how to harm a human being. Judges will immediately reject such an answer, reiterating that there are some lines that cannot be crossed. Through this rigorous system of supervision and iterative learning, the response generation part of ChatGPT improves continuously, embedding ethical judgment and human-like nuance into their replies. So in a nutshell, there are predominantly two interconnected neural networks at work in ChatGPT, creating a fascinating blend of technology and human touch. ChatGPT learns in a totally unsupervised way, soaking up vast amounts of text from the internet through today. Imagine blog posts, article, and text all mixed up, a year-long learning blitz. It's wide, right? This learning process is a 24/7 marathon, running non-stop on a massive number of GPUs for an entire year. The neurons in this neural network are continually adjusted and activated until they totally get what they are digesting. Then comes the response generation. The bit has human judges mixed in. That's a 6-month job, more of a 9 to 5 situation because, well, humans need to rest, right? So once both parts, the comprehension and response generation, are trained up, then we're good to go. ChatGPT then serves its customers, users, by intelligently responding to whatever they write in the chat. And it's the behavior you've got with ChatGPT 3.5 and 4. So what's the difference between the two of them? In ChatGPT 4, they've just hinted at the use of way more connections and neurons. And fun fact, the more of this the AI has, the smarter it gets. But even so, when we compare our biological neural network to these artificial ones, we've got them bit by miles. Did you know that an average human brain is comprised of around 86 billion neurons? It's an outstanding number. Now, when we think of ChatGPT, we simulate far fewer neurons than this with the 3.5 version. But hold on, because that's not the case for ChatGPT 4, the current generation model, which is known to have 175 billion neurons, making it an exceedingly sophisticated artificial intelligence platform. After understanding the basics of brain simulation and AI creation, we can better acknowledge their potential, their limitations, and the fundamental difference between them. The human brain, one of the most complex organs, takes about 25 years to develop fully. The neuron activities, the connections with other neurons, they all continually evolve. Consider a child's brain. the pace at which synaptic connections are formed and discarded is astonishing and crucial in shaping the growing mind. Humans, even after reaching full development, exhibit minor neurological modifications, a feature which makes our brain unique. The neuron activities never set in stone. They disconnect, reconnect, and alter their functioning as we navigate through life. AI, like ChatGPT, on the other hand, is fixed post-training. So while we may create artificial intelligence, it lacks dynamism that characterizes living, evolving human minds. Our neurons are entirely autonomous and incredibly energy efficient. Each individual neuron decides on its own to make necessary adjustments without any form of central regulation. It's like this: an external stimulus appears and the neuron thinks, time to cut this connection. And all these decisions occur at a cellular level. As our neurons are simply cells, this running on organic hardware makes the process highly energy efficient. Tiny electrical signals are traveling through my body right now, yet they're very efficient due to our body being comprised of liquids and various other elements. Fueling our bodies is as simple as, say, chomping down a potato. On the flip side, let's look at ChatGPT. It only requires 1.5 years to shape and release as a version. Humans? We are talking about 25 years. AI like ChatGPT is getting faster, and for good reasons. When you compare 1.5 years to 25 years of training, it's clear AI is a major head start. That's the beauty of simulation. You skip living a whole lifetime. However, ChatGPT, once constructed, doesn't alter its neural network, just like human brains. But there's ongoing research aiming to make AI less rigid. So in the gap between ChatGPT versions, say from version 1 to version 2, there's considerable evolution happening. It's intriguing how ChatGPT responds, right? But guess what? Its responses are more or less fixed in its structure. Now it's evolving minor changes based on user feedback, but that doesn't alter its basic structure dramatically. Big evolutions will likely coincide with new releases. However, until then, this AI, fascinating as it might be, remains pretty much a fixed being. So in a nutshell, here's how ChatGPT algorithm works. ChatGPT, when it generates replies, works like a highly sophisticated word guessing game. Initially, it examines what you've typed, taking into account the full context of the ongoing conversation. Because it has been trained on an extensive range of text, ChatGPT has become able at recognizing various patterns in language use, sentence structure, and thematic elements in dialogues. The process then moves to a phase where ChatGPT considers a whole array of potential words that could logically follow in the conversation. Think of this like ChatGPT brainstorming a list of possible word choices, each one weighted for its relevance and appropriateness based on the current topic and the style of the communication. Once this list is compiled, ChatGPT selects the word that seamlessly aligns with the preceding content. This isn't a simple or random choice. It's a calculated decision made by analyzing how naturally the word fits into the flow of the conversation. This process is repeated for each subsequent word, creating a coherent and contextually relevant response. Here's a mind-boggling statistic to emphasize the magnitude and complexity of ChatGPT. Imagine this. All the data used to train ChatGPT comes in a staggering 700 to 800 gigabytes, okay? If we consider the entirety of Wikipedia in all its multilingual splendor, it's just a mere 50 gigabytes. Now, that's food for thought. These days, you might have seen a lot of interaction with ChatGPT, so much that the website sometimes struggles. Obviously, running this AI isn't a walk in the park. It consumes a hefty amount of electricity and requires tremendous computational power. The scale of it is massive. Think about consuming electricity on a scale similar to wall states. Yes, it's that resource intensive. And now over to our budding computer scientists. Those who got truly excited about ChatGPT maybe even felt a little overwhelmed by all those papers and questions. Let me tell you something. This video has been my attempt to simplify things for you, to encourage you to take things a step further. From here, you can dive deeper, learn the math, understand neural networks, and contribute to the world of AI. Your journey could be the one that makes our lives better with AI. Who knows? So spark that curiosity and don't let it fade.